Hello everyone, my name is Mona Kanson and I'm a PhD student at Queen's University in chemical engineering. I use my chemical engineering knowledge to study the behavior of different viruses, and currently I'm studying the virus that disrupted our whole lives, and you guessed it right, I'm studying the coronavirus. Chemical engineering is the branch in engineering that deals with the production and the manufacture of different products using certain chemical processes. And I always get this question, what is the difference between chemistry and chemical engineering? Well, think about this. Many objects around us contain substances that were once discovered by chemists, and then they were refined and designed by chemical engineers. So whether it's the table that you're sitting at right now, or it's the clothes you're wearing, or even the food you're eating, somewhere along the line, a chemical engineer had something to do with it. As a young girl, I used to love chemistry labs and classes, and I used to always be fascinated by the magic, as I used to call it, that happened in the chemistry lab when we used to mix different liquids together. And then I grew up to like math too. And one day in high school, my chemistry teacher introduced me to the chemical engineering term. And although I did not really understand what it meant back then, I went for it. And honestly, 7 years later, and right now, I'm just happy to have chosen this field. So to give you more insight about the work I do around the coronavirus, I want you to look at this COVID particle. Now, this is the famous corona particle that we've been seeing on the news and in magazines. And when I looked at it, I was actually fascinated with the beauty of it. It's definitely beautiful, but harmful at the same time. So you can see there's a lot of details. You can see the gray sphere, and you can see these red triangles all around it. And these red triangles are the ones that attach to our cells and infect us. So as a chemical engineer, I was interested in studying how does this particle move in our bloodstream and infect our cells. So for that, I basically used my mathematical and my physics knowledge to make a COVID-related model. You can see here, it's a pretty simpler image than the one we just saw, but sometimes it's just enough for engineers to simplify these problems and basically produce results out of it. In the model I produced, you can see that the gray sphere that we just saw in the previous image is modeled here as small balls distributed all around the space. And then I modeled these red triangles as red spheres also distributed all along this gray sphere. And although I did lose some specific characteristics, and it does not really represent the real COVID particle, but it's more than enough to just study how this particle would move, align, and then infect our body cells. Our lives these days revolve around the virus, and I'm more than happy to contribute even 1% to the research that's happening around the coronavirus particle. And to all the girls and boys out there, if you ever decide to be an engineer or a scientist, just know that you're headed on a life path to make our world better.